Every second, this system generates millions of air bubbles with micrometer-level precision. This is not a laboratory. It is a full-scale industrial latex mattress factory. Today, we follow the journey of natural rubber latex from tropical forests to a product worth millions of dollars. The production of natural rubber begins in large-scale rubber plantations. These areas are carefully planned for long-term cultivation, with harvesting cycles that can last for decades. Latex harvesting is not a random activity. It is carried out at specific times of day, most often early in the morning, when internal latex pressure inside the tree is at its peak. Choosing this timing maximizes latex yield and reduces the risk of premature coagulation. Workers use specialized tapping knives to create a very thin cut along the bark of the tree. The depth of the cut is tightly controlled, just enough to reach the latex vessels without damaging the tree's growth layer. Even a small error in this process can directly impact future productivity. Once the cut is made, latex begins to flow from the tree as a milky white liquid. The flow is slow, steady, and continuous for a limited period before gradually thickening as it comes into contact with air. After being collected in cups, latex can exist in two forms, liquid and coagulated. Both forms can be gathered, but liquid latex is typically more valuable because it is better suited for high-quality rubber manufacturing processes. In an industrial agriculture model, natural rubber latex is not processed in a scattered, small-scale manner at individual tapping points. Instead, the latex is centralized from the very beginning of the process. After collection, the latex is pumped directly into large storage tanks and transported by specialized trucks. These vehicles are designed to keep the latex in a stable condition throughout transit, minimizing the risk of premature coagulation before it reaches the factory. Centralized transportation using large trucks not only reduces logistics costs, but also ensures consistency in raw material quality for the entire downstream production line. From this point forward, the latex leaves its natural environment and enters a fully controlled modern industrial system. Upon arrival at the factory, the latex is received in a controlled environment where technical parameters are closely monitored. Each batch is tested for viscosity and dry rubber content, which typically ranges between 30% and 35%. Before entering any forming stages, the latex must go through a filtration process to completely remove impurities such as leaves, debris, and unwanted particles. This step is carried out using automated filtration systems to ensure uniformity of the material. At the same time, a small amount of stabilizing agent is added to prevent the latex from coagulating too early. The goal at this stage is to create a latex mixture that is liquid, clean, and stable, a critical prerequisite for all subsequent industrial processes. Foaming is the most critical stage in the entire production process of rubber mattresses and pillows. At this step, liquid latex is fed into large-capacity foaming machines, where air is introduced in a carefully controlled manner. The foaming process creates millions of microscopic air bubbles evenly distributed throughout the latex mass. The size of these bubbles, their uniformity, and the duration of foaming directly determine the mechanical properties of the final product. In rubber mattress production, the foam structure is engineered to achieve a precise balance between elasticity and body support. For rubber pillows, the foam structure is typically refined to be finer and softer, making it better suited for the head and neck. Because of its decisive role, the foaming stage is constantly monitored by sensors and automated control systems to ensure consistency from batch to batch. Once the foaming process is complete, the latex mixture is transferred to a dedicated forming area for rubber mattresses. Here, the carefully controlled foamed latex is poured into large metal molds. These mattress molds are designed with flat, uniform shapes to produce mattresses with consistent thickness and density across the entire surface. Inside each mold is a system of hundreds of metal pins running vertically from top to bottom. These pins not only create the characteristic ventilation holes found in rubber mattresses, but also play a critical role in evenly distributing heat during subsequent processing stages. The pouring process is carried out with high precision to ensure the latex fills the entire mold cavity, preventing voids or material separation. At this stage, the basic shape of the mattress has been defined, but the material structure remains soft and has not yet fully stabilized. After the mold is sealed, the rubber mattress enters the vulcanization stage inside a heated chamber. The temperature is kept stable between 100 and 115 degrees Celsius, with processing times typically ranging from 30 to 60 minutes, depending on the mattress thickness and specific technical requirements. During this phase, rubber molecules undergo a cross-linking reaction, transforming the original foam structure into a permanently elastic material. This is the critical step that determines durability, load-bearing capacity, and the overall lifespan of the rubber mattress. Once vulcanization is complete, the mattress has achieved its essential mechanical properties, but it must still go through post-vulcanization treatments to ensure long-term safety and stability. After being removed from the mold, the rubber mattress is not ready for use right away and must undergo post-vulcanization processing. At this stage, the mattress is placed into a closed-loop washing system, where clean water is continuously circulated to thoroughly clean both the surface and the internal structure. Multiple washing cycles help remove residual unwanted components from production, including excess proteins, chemical traces, and the natural odor of rubber. Once washing is complete, the mattress moves to the drying stage in a tightly controlled temperature environment. Rather than using high heat for a short period, the drying system maintains a low and stable temperature over an extended time. This approach allows moisture to escape gradually, ensuring the internal structure does not deform or lose elasticity. After drying, the mattress reaches a physically stable state, setting the foundation for the next finishing steps. The mattress is then transferred to the quality control area. Here, each product is systematically evaluated based on predefined technical standards. Compression and recovery tests are conducted to assess load resistance, pressure distribution, and shape retention under long-term use. At the same time, the internal structure is inspected to detect density inconsistencies or potential defects at an early stage. Beyond mechanical properties, dimensional accuracy is also carefully verified. Thickness, length, and width must precisely meet design specifications, reflecting the level of control across the entire production line. Only products within approved tolerance limits are allowed to proceed. Once all technical requirements are met, the mattress core moves to the surface finishing stage through fabric encasing. This cover is typically made from breathable, skin-friendly textiles such as cotton, bamboo, or tencel. In addition to protecting the rubber core, the cover enhances comfort and helps regulate temperature during use. The final step in the production line is packaging. Rubber mattresses are packaged under controlled conditions to minimize exposure to dust, moisture, and environmental factors during transportation and storage. At this point, the product is fully prepared for market distribution. Taken as a whole, the finishing stage serves as the final verification layer for the entire manufacturing process. Through rigorous quality control and finishing systems, modern factories ensure that every rubber mattress leaving the production line meets the consistency and reliability required for large-scale industrial manufacturing. Running in parallel with the mattress line, the rubber pillow production area operates as an independent system with its own technical requirements. The latex mixture used for pillows, while sourced from the same raw material, has its foam structure specifically refined to support the head and neck. The latex is poured into smaller molds with more complex shapes than mattress molds. These molds are designed according to ergonomic principles, featuring contours, curves, and waves that support different contact zones of the body. Inside each pillow mold is a vertical system of metal pins. These pins create ventilation holes that reduce product weight, improve airflow, and limit heat buildup during use. At the molding stage itself, the functional shape of the pillow is clearly defined, directly reflecting the product's intended use. Once the pillow molds are sealed, the products are transferred to the vulcanization chamber under temperature conditions similar to rubber mattresses, typically between 100 and 115 degrees Celsius. However, due to the smaller mold size and different structural design, pillow vulcanization times are shorter, usually ranging from 20 to 40 minutes. During this phase, rubber molecules undergo cross-linking, allowing the pillow to achieve the elasticity required to quickly recover its shape after compression. This process is essential to creating the stable, long-lasting support that defines rubber pillows. After vulcanization is complete, the rubber pillow core is removed from the mold and goes through multiple washing cycles using clean water. This step is designed to fully eliminate residual proteins, raw latex odors, and any remaining chemicals on the product surface. Next, the pillows are dried under low temperature conditions to stabilize both shape and internal structure. Careful control of temperature and drying time is critical to preserving elasticity and preventing shrinkage or deformation. Once these steps are completed, the rubber pillow core reaches a technically finished state and is ready to move into the final quality control phase. In the inspection area, each pillow core is evaluated against specific technical criteria. Beyond mechanical properties, the overall shape of the pillow is compared against the original design. Ergonomic contours, recessed zones, and pillow height must precisely match the specifications established during the molding stage. Any deviation beyond allowable tolerances results in the product being rejected or reprocessed. After passing quality inspection, the pillow core moves to the fabric covering stage. The cover is typically made from breathable, skin-friendly materials such as cotton, bamboo, or tencel. This covering not only protects the rubber core, but also enhances user comfort through improved moisture absorption and temperature regulation. Finally, the rubber pillows are packaged in a controlled environment to limit exposure to dust and humidity. At this point, the product has completed the entire industrial production chain and is ready for distribution, becoming part of everyday life for consumers. At a broader level, this process illustrates how an agricultural raw material can be transformed into a high-value product through the integration of technology, machinery, and modern quality control systems. It also highlights the growing role of industrialization in modern agriculture and agricultural processing. From the first drops of latex flowing from a rubber tree through tightly controlled processes and modern machinery, agriculture today has moved far beyond the idea of traditional farming. Natural rubber is a clear example of how technology and industrialization can elevate agricultural raw materials, transforming them into products that are part of everyday life. If you are interested in large-scale manufacturing processes and how technology is reshaping modern agriculture, keep watching our upcoming videos. Don't forget to subscribe to the channel and leave a comment to share your thoughts or questions about today's topic.